In this video, we're going to talk a little bit about the three fundamental principles of mechanics and a new principle that we're going to be adding in E&M. So in mechanics, what we had was a system, and that system had properties like linear momentum, energy, and angular momentum. And those were influenced by forces, work and thermal exchanges, and torques that were due to the surroundings. And what we were able to do was to develop fundamental principles that tell us about how each of these quantities changes as a result of interactions with its surroundings. So the first one was how the linear momentum of the system changed as a result of external forces that act over a certain amount of time. Now, what was interesting was when we chose systems that didn't have external forces. So if we were able to argue that those external forces vanished, we would have linear momentum conservation. That is, the momentum before and after some interaction was exactly the same for the total system. If we looked at the change in energy of a system, that was a result of work and thermal exchanges. And similarly, if we could argue that the work and thermal exchanges vanished, that is, we could pick a system where there was no outside influence, we had energy conservation, which was a very powerful tool for us in explaining motion before and after some sort of interaction. Finally, angular momentum was a result of external torques that occurred over some period of time. And if, again, we could choose a system where the torques vanished, that is, where there was no outside influence of twisting or rotation, then the angular momentum of that system was also conserved, which is super useful. Now, we're going to add to this in E&M, we're going to add a property of charge, which is influenced by a thing that we will call current. So it's carrying charge across the boundary. And so we have a new fundamental principle in E&M, which is that the amount of charge that the system has is a result of the current that's carried across the boundary over some amount of time. If we can choose a system where there's no current carried across the boundary, so if in this case I vanishes, then we have charge conservation. That means before and after some interaction of our system, the total charge of that system is constant. So these four principles become our fundamental principles for E&M, and we will make use of them this semester. We will start working with this later in the semester, but it's just sort of a broad overview of all of the principles that apply in E&M.